Okay, let's recap the lesson. So it's kind of a big day today. We talked about this thing called composite functions. What composite function means is simply putting one function into another. So we're going to put one function into another. So if it says f of g of x, that means g of x is actually put into f of x. Or it says g of f of x, that means fx is put into g of x. So let me show you, because see how it's inside, fx is inside of g, or g is inside of f. Okay, so let me show you an example. Okay, so I've got two functions. I've got fx equals x squared plus 2x, and my other function is g of x is equal to the square root of x plus 1. So I've already done this work, but see what I'm doing. Okay, so if I see f of g of x has to go into, so put g of x into fx. So I take all of it and put it into x. And I put it into both x's, because I have to put it in for x, so I rewrite it. So instead of writing x squared, I wrote the square root of x plus 1, because that is g of x. And instead of writing 2x, instead of writing x, I wrote the square root of x plus 1. Okay? And then that's it. I just put one into the other. Now, g of fx is just the same thing. We're going to put f of x, which is this one, into g of x. Okay? So then we take this function, we plug it into g of x, which should put it into your x. So we get the square root of, not x, but what fx is, which is your x squared plus 1. Okay? That's all this means. Now, why do we learn this? Well, it turns out, turn the page, that we get a rule that says if you take f of f inverse of x, it'll equal x, and f inverse of x should equal x. If you can prove this, then you've proven something is function. So we took a look at a graph. Okay, let's take a regular function. So I made one up. So I said, here's f of x. And let's find its inverse. So to find its inverse, again, the first thing we do is change, I just want to change that to y. f x, y, same thing. And then, to do an inverse, I switch x and y. So y and x switch. To make it look better, I solve for y. So, okay, to solve for y, I went minus 2, and then divided by 3. So my inverse is this. It is a 1/3 x minus 2/3. Okay? So now I'm going to take this, and that's my inverse. Okay, so these two functions, 3x plus 2 and a 1/3 x minus 2/3, these two are inverses. Okay, so we want to use this proof. So if we plug the inverse into the function, it should equal x. And if we take the function and plug it into the inverse, it should equal x. So we did that. So we wrote them out down again. Here's our function. Here's our inverse. And the first thing I did is f of f inverse of x. So the inverse is going to go into fx. So I took this 1/3 x minus 2/3 and I put it right there. Okay, so I rewrote it. 3, not x, but the inverse. Put this right there and for x. And then I simplified it. Okay, 3 over 3 is x. I get a regular 2. Negative 2 over 2, it equals x. And it should equal x. That's what my rule says. Okay? Did the other. Took the f of x and put it into the inverse. So I took the f of x, that's this one, and put it into the inverse. I put it right there for x. Okay? So instead of writing my f of x, instead of writing the x right here, I wrote my f of x. Okay, so then I distributed. I get a 3 over 3, or x, plus 2/3. 2/3 cancel, I get an x. Okay, and that's what we want to show. If we can do this, if we can plug an inverse into the function, or the function into the inverse, they both must equal x to prove that they are inverses. Okay, and that's what we did for our lesson. All right, Matthew goes through that as well. So if you have questions, come see me.